Hi folks, we are here with Dr. N.S. Murthy, Chairperson, Department of Electronics Communication Engineering, Amrita School of Engineering, Amrita Vishwavidyapeetham, Bangalore. Sir, we are happy to have you here and welcome for this talk.
Thank you.
How do you make the changes of your curriculum for your department ECE, considering the requirements of our students maybe after 10-15 years? Or considering the requirements or the present requirement of our students. In my opinion, don't you think it is correct to look at what is required after 10-15 years rather than looking at things which are currently required? So if you understand the basic requirements of industry after maybe 10 years, can we bring those into the curriculum? To bring into those things into the curriculum, what is the department doing, sir?
Okay, it's a very valid and very important question.
Thank you, sir.
The first thing is there are two things what we teach. One is the fundamentals, because the fundamentals more or less remain the same and they are extremely important because everything is built on the fundamental.
Fine, sir.
Okay, so in the first year and second year mostly we teach the fundamentals, basics, so that the students have an excellent foundation. Then comes what is the innovation, what are the new technologies or what is called the applied type of work which is to be done. So that is where the things change very fast. They change even quarterly basis and so.
Can I interrupt you here, sir? I'm sure in the recent Education 4.0, the companies really don't look at students' skill or the knowledge, right? Everybody, once they complete the fourth year, they have the skill and the knowledge of engineering. But in the Education 4.0, they talk about problem-solving skill. How does your student solve the problem? How does he think critically? It's not just thinking, that's talking about the critical thinking, that's number 2. Number 3, we talk about the innovation. And number 4, we talk about the creativity. I mean, engineers must be a creator rather. So are you trying to push this into the curriculum to make them futuristic education for our students? That's why I just wanted to. Sorry to interrupt this, otherwise this would have been a separate talk in between. So can I take on from there and over to you, sir?
So what we do for the students to be industry ready, ready has got many dimensions. One thing is of course their knowledge and the ability to apply the whatever knowledge they have earned, and how to think innovatively and not just to look back what is there in the memory, but create a new way of solving the problems. So for making them industry ready, first of all in the curriculum aspect we have people from industry as a faculty, and also in every board of studies meeting when we decide on the curriculum for the next 2 years or 4 years, the people from industry are always involved. So the industry readiness in terms of the curriculum and what type of experiments they have to do, those type of things are taken care in the curriculum through the board of studies. Then how the people apply and how innovative they are, it comes more from how they do the projects. That is where the people will apply what they have learned. So the projects are 2 types. One is of course the in-house projects where our students do here. For that, for the review and already the interaction, we invite people from industry, and many of our good students also go for internships to do the projects in the company itself.
So I'm going to ask you 2 questions. How easy it is to learn ECE, not because of ECE, or how difficult it is to learn ECE? You can either take this or the other question. So which you like to take? How easy or how difficult it is? Which you like to take, sir?
I don't say it is difficult because I have done it. Okay. If I have done, I think anybody can do it. And the thing is, we should have what is the difference between some other one is this is mathematics is quite important.
Okay. You must be really.
They should have very good mathematics background, and basically ECE is more applied physics. It is actually most of the physics which is applied. That is what is electronics and communication.
Okay.
So they should have good fundamentals in mathematics and physics, and that aptitude to do to this. It is not easy. So that I don't say it is.
It is not easy, but also not difficult.
Not difficult.
Okay. And what is the future for those students who graduate in ECE, sir? What do you think is the industry going to take on? I mean, what do you think is the future of our children who complete the ECE and become engineers?
This is a very good question which I like the most, because ECE is such a branch. Once you do ECE, you can go anywhere. The paths are open in all directions.
So it's a junction. It's a railway junction, not the dead end for a student.
From ECE, you can go in any direction. Why I say this is, In ECE, we don't teach not only just the hardware part of the electronics or communication, we also teach the software which works with that electronics. Okay. So, nowadays we teach all the C++, okay, Java or even machine
Python,
learning, Python, all these courses we are teaching for ECE. So, ECE nowadays no system is purely hardware, every system has got a software
Absolutely.
layer on the hardware. So, unless the electronics engineer learns both hardware and software at the system level, he is not a complete ECE engineer.
So can I say your students of ECE are jack of all trades and master of everything?
No, it is the other way. They may not be masters,
Master,
but their
aware of-
foundation is good enough to go in any direction.
Absolutely.